Okay, so one of the things I wanted you to kind of maybe see or not, but as you move the time, regardless of what you were looking for, did you kind of see a sway in where the stars were? The constellations kind of moved. And we'll be talking more about that movement. Actually, this gets to that last question. For this semester, it works really good if we talk about the clock as being Polaris. And I think I mentioned this the other day. Okay, when I put the sun in the middle of the room, here, right here, okay, and the Earth orbits the sun. Oh, counterclockwise, yeah, I'm doing it right. Okay, and the Earth's axis of rotation is pointed towards Polaris. And honestly, the reason we see the sun move is because the Earth is spinning on its axis. Okay, and it's that motion that makes the sun appear to move across nighttime sky, or daytime sky, excuse me, the sun. And it's that same motion that makes the stars move. So these are star trails. They're beautiful. Let me see if this video will play for us now. It's like 1 minute long. On my list of things to do right now is to capture images, we call it astrophotography, but we'll see. But, so this is going to take you out to the internet and a video of watching the motion of the stars. It's got speech bubbles. Oh, you're okay, little computer. Time lapse of stars in Death Valley. Road trip.
Feel it in your heart. Feel it in your soul. Let the music take control. Caramba. New Bud Light Lime Apple Arena. Fiesta forever.
The beauty is you get so far away from the city and so far away from civilization that the skies are so dark, you can just see things you didn't even know existed up there. This time we used the moon to sort of paint the foreground, so you get this effect where you actually can see the ground, you can see the desert, but also see the stars moving above it, which really gives it kind of a surreal, almost fake-looking view, but that's kind of just what we were really into. And then in the later part of the video, you actually see where the moon goes away and we get into the really rich, dark star stuff. So with the star trails and that kind of thing.
So he just kind of alludes to a longer video, but that gets you kind of an idea. So I haven't yet, but if I had a marker, and that's Polaris, I would make like that the bullseye, the star Polaris, and I would draw a circle like counterclockwise around it. Can you just I would get so much trouble, okay? So that's what stars do, okay? Now, if I make a circle big enough, I'm going to hit the floor. In real life, I hit the horizon, I hit the Earth. So actually, if you go counterclockwise, we said this is what direction? What direction is that? East, very good. If you go counterclockwise from Polaris, you make bigger and bigger circles. You get a rise in the east and a set in the west. Okay, and the reason stars move throughout the course of the night is the same reason that the sun moves throughout the course of the night, because the Earth is spinning on its axis. All right, so, continue. Okay. So on that sky map I gave y'all, let's see if I brought mine, that black and white sky map, yeah, here it is, for August. It's good about August 15th, but that's about as good as we get. Okay. There's like a gray region here, and that gray region is the Milky Way. Okay. That gray region is the Milky Way. The darker the skies, the more you're likely to see the dot, 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 dot. And it looks like haze, but if you get a pair of binoculars, you're going to see that those are just like millions of stars. I asked Siri this question yesterday, really. I said, how many stars, Siri, are there in our galaxy? And she said, via Wolfram Alpha, 200 to 400 billion stars. 200 to 400 billion stars in our Milky Way galaxy. I said, I know. So I said, wow, that's a lot of stars. And I said, all right, Siri, how many galaxies? This is the Milky Way galaxy. How many galaxies? And she came back with, again, same source, 170 billion galaxies. Now that's an estimated number, 170 billion galaxies. Well, so is the 200 to 400 billion stars in our own galaxy. I just thought that's a lot of stars. Okay. So to me, this whole class is humbling. I'm like, cool, we are awesome. Well, yeah. Put in perspective, there's a lot of awesomeness out there. So only in these next few slides do I talk officially in lecture about constellations. So, I got the iPads out. We kind of did a little bit with the sky map, so we might be doing more with that later. Each week I'm going to give you, did I give you a constellation of the week? Did I give you Ursa Major yet?
Yes. Yeah.
Okay, good. Each week I'm going to hit a constellation, But my best suggestion, if you want to be able to see the patterns in the nighttime sky, is to come to the labs that I'm offering. Okay, and the other thing is you don't need me. Okay, you need determination to understand the patterns in the nighttime sky. You need determination and just spend time out there, comparing the star patterns you see with the star patterns on the map. Okay, so here's the deal. We talked about motion at the end of chapter 1. Okay, so if I make the sun here, the sun's here, and we said that the Earth is orbiting the sun like the other planets. Okay, which is awesome. But one of the things we know about objects in motion is that as we move, okay, our perspective of other objects change. That being, I'm pointing out to those stars that make up the constellations. Honestly, those stars, for instance, I'm going to pick on the constellation Orion. Everybody loves Orion. I'm going to pick on Orion. I'm going to tell you that those stars that make up that pattern of that hunter, they're not really on the same page, so to speak. They are at different locations. So I go back to our motion. Okay, the fact that they are at different locations, okay, when something's like that, the stars kind of change their relative position to each other as we move. They should. But I'm going to try to convince you of this, that as something like stars are way out there, it's called parallax. The farther away something is, okay, if the observer's moving, the farther away they're looking at something like stars, it doesn't matter if they're at different distances. They all just kind of keep the same wonderful pattern. Okay, it's called parallax. All right, so I'm picking on Orion. So just to kind of remind you about Orion, I'll make a different color so it shows up a little better. Okay. I say remind you because when we were talking about nebula, okay, down here, oh goodness. Okay, so anyway, so Orion has a belt portion. This is his belt. And then he has a sword portion. Okay, that's the sword. Okay, these are his shoulders. These are his knees of his toga. Okay, so we talked about this sword part when we talked about nebula. I got my wrong slide up here. So one of the things, I will emphasize it on the slide because I look for things to test you over. And what really is an easy question is how many constellations are there? Now, it's easy, but it's not easy. It's funny because it's easy. Everything in the universe is matter and energy. That's easy. No, it's not. There are 88 constellations. The thing is, I'm going to try to convince you we don't see all of the constellations. Okay, we aren't privy to all 88, but what scientists have done, probably before scientists, what sky lovers have done, is to break the sky up into 88 sections. So you kind of see the boundaries. The yellow are the boundaries. The thing about boundaries, then, for instance, is like it or not, and we like it, is everything within this boundary is a star of Orion, even if it doesn't make him at all. It's one of Orion's stars because it's in that boundary. Makes sense. Just kind of a little bit of a hint then. The brightest star in Orion would be called Alpha Orion. What's the second brightest one? What comes after Alpha? Beta. Beta Orion. And is it Gamma? I think so. Gamma Orion. Okay, you get the idea. So the brightest of that set. So that's kind of how that goes. Usually, that's how it goes. Okay, some constellations. Hopefully we'll see them Thursday night. If we don't see them Thursday night, we will. We'll get there. And if you're like me, one of the things that's reassuring are those patterns of stars in the nighttime sky. I'm like, yes. I mean, I can be away from home, a little bit homesick, and I look up and I see the Big Dipper, and I'm like, yes. It's a relatively bright set of stars. And the thing about the Big Dipper is we have a handle portion. Okay, those are the stars associated with the handle. And then we have a bowl portion. Do you see there was a handle on the bowl? So the thing about the Big Dipper in general, okay, is we can use the Big Dipper to kind of orient ourselves to some other important parts of the nighttime sky. Polaris, it's the clock for the semester. How do you find it? If you can find the Big Dipper, you can find that star. Bless you. So the thing about the Big Dipper is you're going to see that it'll move throughout the course of the night counterclockwise around the North Star. But if you can find what we call the far stars in the bowl, these are actually what we call pointer stars. And if you go up, okay, they point to, it's not very bright, unfortunately. This little star right here that has the arrow pointing to it, that's Polaris. And notice that Polaris is actually in the handle of the Little Dipper. And this is very faint, okay? These guys up here, in fact, the Little Dipper is a way, if you can see it or not, it's kind of a way of saying, oh, you might have some wispy clouds that are kind of preventing you from seeing really cool stuff. Or you might not be able to see the Little Dipper because of the lights kind of around you. So that's how that works. Also, the Big Dipper can help you find, bless you, sometimes, bless you, some stars have names. I think I mentioned that on Monday. A lot of names I can't pronounce. But I can pronounce the name Arcturus. And it's a really bright kind of orange star, and you can use the handle of the Big Dipper to arc to Arcturus. And then if it's up, you can, what we say, speed on to the next bright star called Spica. So Arcturus and Spica are two stars in different constellations. Just a way to kind of orient yourself. Sometimes in a given night, you know, I volunteer out of that Whitty Observatory, and you know, have people come, and one of the things that we all do is we see a bright star like Arcturus and we think it's a planet. Really common. Have you ever heard that stars twinkle, but planets are steady? There's something to be said for that. Last but not least, up here, you see the constellation Leo, which is one of the zodiac constellations. We're going to talk more about that here in this chapter. Leo has two parts. It has the sickle part. I don't know if that looks like a sickle to you, like one of those dangerous sort of things you cut grass with, right? Okay, or a backward question mark. And then it has, this is the back. That little triangle is the butt of Leo. So these are all just things to kind of help you start to kind of think about looking for those patterns in the nighttime sky. I'll warn you that as you kind of struggle with seeing different shapes in the nighttime sky, there are a lot of squares up there. You're like, oh. And it's fun to hear like little kids say that they see different things. I'm like, oh, that is so cool. So one of my dreams or thoughts is that these 88 constellations, I just wonder if like 100 years, 200 years, if the kids are going to take over and call them something else. I don't know. It could happen. Different cultures see different things. I think that's neat too. All right. So the constellations we cover, these are like figures from your textbook. These constellations are things that I could like introduce on an exam. But like I said, I'm going to give you an exam review sheet to kind of narrow down. So we have 2 triangles, actually starting with, be here before we know it, the winter triangle. And I heard today somebody say that our temperatures this winter, they're forecasting, are going to be like colder, 5 to 10 degrees colder than normal, and lots of fluffy white stuff. Anyway, I know, winter triangle. We have a summer triangle coming up too, and actually summer triangle is what we're seeing right now. But both triangles have 3 stars, and these 3 stars are in totally different constellations. So the winter triangle we're going to be seeing, 1 star is in Orion. I pronounce it Betelgeuse. I've also heard it, just like the show. I've also heard it pronounced Betelgeuse, so I don't know. So one of the 3 stars is Betelgeuse. One of the 3 stars is in what we call Minor means little, and Canis means dog. So Canis Minor is the little dog. Actually, it's little. There's only like 2 stars that kind of major make it, and one of them is pretty bright, called Procyon. Okay, and then the last star. So, if Canis Minor is little dog, what's Canis Major?
Big dog.
Big dog. It totally is. Okay, so a star called Sirius. Seriously, I'm sorry, it never gets old. So I don't know if you remember in your notes, we said that this star, Sirius, is 8 light years from us. We used it as an example. Okay. Now, one of the things, and it's not on the slide, but I want you to start kind of thinking about this, is that the miscellaneous stars we see are all in our galaxy. Those stars are in our galaxy. I just think that is so cool. Okay. All right, summer triangle. So again, 3 stars and 3 different constellations, and this is what you can see now. So you see the dot, 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 dot. Oops, sorry, go back. You see the dot, 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 dot. Okay, that is the Milky Way. And this, can you guys see this? This set of stars, it goes by 3 different names. Okay, is it? Well, I guess 3 different names. The like mythology name is Cygnus. Okay, and Cygnus is actually a swan, so that's the second name, Cygnus the swan, 2 names. But the other name would be the Northern Cross, okay, because we see it in the northern hemisphere. We can see this star, this set of stars, okay. All right, so the star of interest that makes up the summer triangle in Cygnus is Deneb. Then we go to, doesn't that look like a fish? Does this look like a fish to you? Okay. Maybe it's because I'm imprinting that on you. But actually it's a lyre, kind of like it's called Lyra, which translates to a lyre, like has strings. Okay. So that's a neat little constellation. And they have a very bright star, pretty blue star. Did you guys know that stars are different colors? We'll be talking about that. Yeah, that's a very blue star. Called Vega, is the second of 3, and the third of 3 is Altair in Aquila the Eagle. Okay, it doesn't really look like an eagle there. So a lot of times the convention, let me look at the sky map. Yeah, a lot of times with constellations, the convention on a sky map is to make them in caps. So we have a couple other miscellaneous constellations. Delphinus, I love Delphinus. Dolphin, does it look like a dolphin? It is. Okay. It's so fun. And then Sagitta is an arrow. Those are kind of fun, because if you find the summer triangle, you should be able to find those if the skies are dark enough. Okay. Well, I don't emphasize it on my slides, but I'm going to add it to this slide. This concept of something called the celestial sphere is what we call a scientific model. I'll put SCI for scientific model. Okay, and your textbook, if you're reading along in your textbook for Chapter 2, they will talk about what are the aspects of a scientific model. But just like we said, and you guys played around, you guys know that the stars do like the sun. They actually appear to rise in the east and set in the west. If they're close enough to Polaris, they're going to go counterclockwise, okay? I mean, that all can be explained if we basically take all the stars and say the Earth is steady, or I guess we can do this. We can say that those stars are imprinted, okay, they're stuck, and the Earth is spinning inside that. This thing, as I hold out my hands to where the stars are, that is a model that works, and we call that the celestial sphere. Okay, it's a model. Is it the real deal? Are all those stars really kind of at the same distance and stuck in outer space like that? No. But it kind of works to a certain degree, explain what we're seeing. Okay. So the stars are rigidly imprinted on this big hollow sphere. You're going to see a couple pictures here in a minute. And smack dab in the middle of this big hollow sphere, makes me think about a Tootsie Roll, but is the Earth. Okay, and the Earth is spinning. So then all of those stars out there, again, you can't see we can't see stars in the southern hemisphere, okay, but we can in the northern hemisphere. There are 88 constellations. Okay, so as the Earth is in the middle there, okay, the Earth completes one rotation every 24 hours. Okay, so, and its axis of rotation is tilted, and it's orbiting the sun. So when we especially kind of take those last few things into consideration, in our model of the celestial sphere, we're going to have to account for the sun too. Okay, thou shalt not forget the sun. But we can do that. And I'll show you what the celestial sphere looks like when you take the sun into consideration. There is the celestial sphere. So that light blue is the hollow ball. Okay, in the middle you see the Earth, and it's spinning. One of the things you might notice right away about the Earth is it's not tilted. It's right straight up. I made a big hairy deal, okay, sometimes about the Earth's axis of rotation being tilted. But in this scenario, we set it right up. So, some features of the celestial sphere. Okay, the ecliptic. Let me kind of make sure we're all on the same page with where the ecliptic is. The ecliptic is this kind of purplish line right there. I know, this kind of hurts people's brains. It hurts my brain. Because if I remind you what I said the ecliptic was a minute from previous lecture, okay, I'm going to go ahead, tilt that puppy, point it towards Polaris. I'm going to put the sun right there, and I'm going to go ahead and orbit the sun once a year. Okay, this is my Earth going about the sun. Okay, so the ecliptic is actually where the sun appears to be. Okay, the sun and the planets, quite frankly, which we haven't talked about yet. So Friday, I'll bring in like a physical celestial sphere, and you're going to see actually the locations of the sun throughout the course of the year on this imaginary hollow ball. Okay, so we have the ecliptic kind of tilted, and the ecliptic is tilted relative to, like this slide says up here, something called the celestial equator. We get this celestial equator by basically taking the Earth's equator and expanding it out. Okay? We get the celestial poles by taking the Earth's south and north pole and extending them up. But that ecliptic, the path that the sun takes against the background stars of the celestial sphere, is tilted. Okay. So just another figure. Can you see where this is the celestial sphere and there is the Earth? And that dot, 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 that actually is showing you the sun throughout the course of the year. You can see the boundaries. They aren't in yellow this time, but the kind of the light blue boundaries of each constellation. These names should sound familiar here in the northern hemisphere. These names, maybe not so much. Of course, Aquarius, yes. Cetus, oh, you can see it low on the sky. But these guys, I have not seen them before. It's on my bucket list. Okay. So, just to kind of finish up a few slides about, actually, let's take a running start, and we're going to start here on Friday. That's okay with everybody else. Okay? Okay, so keep your fingers crossed about tomorrow night. And any questions, you can always call me or email me, but outgoing message on my phone and an email to you when I decide. At least 2 hours before I'll decide, probably before that.
About how long do they last?
How long do they last? Depend upon how many students are there, but you can probably get enough to write about in 20 minutes, 15, 20 minutes.
My boyfriend has to be at work at 10:30, that's why I was like, well,
Yeah.
so I'll have like an hour and a half before I have to be back with my kids. So
Okay.
that's why I was just-
And did you hear, I don't know how old your kids are, but family and kids, friends,
They're
everybody's
only 8
welcome
and
to
5,
come.
So their bedtime's 9.
Yeah.
They're already in bed.
No
by
crabby
then.
kids. I'm just
They
kidding.
won't be crabby, but they will be the next day.
You'll pay for that.
Actually, the teachers